Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Yes, today we are looking at this question. It says that an 80 kilogram driver accelerates his 2000 kilogram truck from rest at the rate of 8 meters per second. When you look at that one, that's acceleration. The truck's displacement is that. And the question says that calculate power expended to accomplish this in kilowatts. Okay, they want the power expended to accomplish this. We are looking at the driver inside the truck, and he accelerates at that rate for 300 meters. So what is the power produced during this situation? Okay, when you look at this, the best equation to apply is P, or power, equals to change in kinetic energy over time, or over change in time. Okay. So if that is what we are going to use, then we can expand it and find out what we have. When you expand this one, what are you going to have? I have mvf squared minus I have mvi squared. This one over time. Okay. So let us look at what we have. What do we have here? We know initial velocity. The truck was initially at rest. So we know Vi is 0. We know the mass. The mass involves the driver plus the truck. So what do you get out of this one is going to be that. Okay. So what do we have? That is all. We don't have the final velocity, and we don't have time. But guess what? They are calculatable. Okay, let's look at this. Okay, let us start with calculating VF. Okay, what do we have in this case? We know acceleration, which is 8 meters per second squared. We know initial velocity. What is it? 0. We are looking for final velocity. What is it? Wanted. What else do we know? It is the displacement, which is 300 meters. So when you look at this data, it takes you to our equation. Okay. What equation does it, which has this? It is the second equation of motion. Vf squared is equal to Vi squared plus 2a delta x. So if you substitute in this, we are it's Vf which we are looking for, but we know initial velocity, which is 0 squared, plus 2 times acceleration, which is 8, times displacement, which is 300. So what are you going to get here? Let's see. So we got that 4,800 and we get our VF as the square root of that. And the answer comes to be 69.28 meters per second. So that is that. We know the final velocity, but we don't have time. But guess what? Time is also calculatable. So we can say calculate delta t. Okay, let's look at the information we have for delta t. You have our acceleration, which is 8 meters per second squared. We are looking for delta t. We know initial velocity, which is 0, and we know displacement, which is 300 meters. With this, then you look for the right equation. What's going to be the right equation? The right equation is this one. Delta x is equal to vi delta t plus a half a delta t squared. Okay, so delta x, yes, we know it. It's 300. Vi is 0 times delta t, which we don't know. This one gives you a half times acceleration, which is 8 times delta t squared. Okay, from here you can have 300, which is equal to 4 delta t squared. So from here, what do we do? You divide both sides by 4, so it's going to be 300 divided by 4, giving you delta t squared. And the square root of this is going to give you that. So delta t is going to be the square root of that. And it becomes 8.66 seconds. So, yes, we have found the missing pieces. So from there, what do? We just go ahead and substitute in. So we are going to have here half times our mass, which is 2080, times the final velocity, which we've found as 69.28 squared, minus half times the same mass times initial velocity, which is 0, all this one over our time, which is 8.66. What you get out of this is going to be our power. So that is that. 576 409.6 watts. But the question says our answer must be expressed in kilowatts. What do we do? You divide this by 1,000, and what do we have? 1, 2, 3. So it's going to be 5, 7, 6.41 kilowatts. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences. Silver Bullet, and it's me, Richard, here. Yes, Yeah, as we are signing out, we have to remind you to subscribe, to like, to comment, to share. Yes, we are simply the best. See you then. Bye bye.